Hi, everybody. This is Morgan here with Positive Approach to Math. We are beginning our equations unit or topic. So we're going to start off with solving one-step equations. You're going to see in this topic that the lessons really build. So the skills we're learning in this lesson are going to carry through with lesson 2, are then going to translate into lesson 3, so on and so forth. This is a super important lesson for those of us in Algebra 1 who plan to take math beyond Algebra 1 because you're going to be solving equations in all of your math classes to follow. So these skills are important, and so it's really crucial that we get a great foundation to set us up for success. So let's get started talking a little bit about solving equations. We're going to start just in this lesson with one-step equations, and then we will move right along. So for your information here, is talking about what it means to solve an equation. So to solve an equation is basically asking us to find the value or values of your variable that will make that statement true. However, when we're solving equations, a lot of times we are undoing operations. So we call those the inverse operations. So if I have to undo addition, I would apply its inverse. And what's important about solving equations is you need to keep the equation balanced. I always talk about it like a barbell at the gym, right? So if I add a 25-pound plate, on the left-hand side of that barbell, I have to keep it balanced and add a 25-pound plate on the right-hand side. Same thing if I think something's a little too heavy and I'm going to take off a 10-pound plate on the left-hand side of that barbell. To keep it balanced, I need to take off a 10-pound plate on that right-hand side of that barbell. So when I grab it, I'm not lopsided. So the same thing goes for equations. If I do one thing on the left-hand side of that equation, I must also do it on the right-hand side if I'm going to do an opposite or an inverse operation. So, talking about our properties, we have 4 properties of equality. You probably know most of them or all of them already. We have the addition property of equality, which is telling us if I have this basic A equals B, right? If I want to keep it balanced by addition, if I add some value on the left plus C, I have to add that same value on the right plus C to keep it an equivalent expression. That's our addition property of equality. Our subtraction property is telling us that if I subtract my left-hand side by a particular value, say minus C, I have to subtract that right-hand side by C as well to keep that equation balanced. Same thing, think about that barbell. It got too heavy for me, so I had to take a 10-pound plate off the left-hand side. So to keep it balanced, I have to subtract or take a 10-pound plate off that right-hand side. Our multiplication property of equality is telling us that if I multiply the left-hand side by some value C, I have to also multiply that right-hand side by that value of C to keep the equation balanced. And last but not least, if I have to divide by C, I would have to divide by, on the left-hand side, I have to divide by C on the right-hand side. That's your division property of equality. So, when we're solving equations, when you see something being added or subtracted, you do the opposite operation. So it's important to note that addition and subtraction, they kind of go hand in hand. They're inverses of one another. So the opposite of adding would be subtracting, and the opposite of subtracting would be adding. So if I need to undo that addition property, I'm going to subtract on both sides and apply that property of equality. Multiplication and division also are inverse properties of one another. So if I see something that says 5 times a variable and I want to get rid of that multiplication, I'm going to apply the division property of equality. I'm going to divide both sides by 5. And like I said, if I divide one side, you must divide the other side. So they go hand in hand. They undo each other. Think of one of the properties is zipping up your jacket and the inverse is unzipping and you're back to where you began, sort of deal. Like think of it like that. So when we're solving equations, we use the inverse properties over and over again to isolate. You're gonna see me put the variable in a box to isolate our variables, okay? So inverse is a super important word that you're going to see in math moving forward. Think of it as undoing an operation, or think of it as the opposite operation. And what you need to just recall is that the opposite of addition is subtraction, and the opposite of subtraction is addition, and then the opposite of multiplication is division, and the opposite of division is multiplication. Okay, so let's just kind of dive right into it with our examples here. So I'm going to slide this up. Let's see if we can squeeze our examples all in. There we go. And when I solve equations, you're going to see me take the skills we're doing today and we're going to build on them, but my foundation is always going to be the same. So when I have an equation, I kind of draw a bridge for myself. So I'm going to use orange as my bridge, okay? And that shows me the two sides. So the x plus 4 is the left and the 10 is the right. That is my left-hand side of my barbell, the right-hand side of my barbell. I always like to put my variable in the box. That's the thing I want to get by itself. So I want to keep that where it is, that x, and I want to get rid of everything outside of the box. So I look and I say, okay, I currently see that there is a plus 4 happening to the x. I need to move that plus 4 to the other side because I only want x by itself on the left-hand side, right? So I say, okay, what operation will undo adding 4? What is the opposite of plus 4? And hopefully you're responding subtracting or minus 4, right? So now I'm going to apply the subtraction property of equality because I'm going to undo that addition by subtracting. And here's the thing, if I subtract 4 on that left-hand side of that line, I have to subtract 4 on that right-hand side. Whoopsie, that's not what I wanted. I have to keep this guy balanced, right? We can't have it get like this, right? We want to keep it balanced. I always like to draw an arrow for whatever's just being brought down so I don't miss it. So I'm going to subtract or bring my x down, and then I'm going to do 4 minus 4, which is 0, right? They cancel, it goes to nothing. So I'm not going to write plus 0. I'm going to say, okay, I got my x by itself. And then I'm going to say, okay, what's 10 minus 4? That is 6. And so we solve this equation when x is 6, the left-hand side and the right-hand side will be equal. And here's the thing, I love solving equations because you can always, always, always check your work. And I'm not going to do this for every one of them, but I'm just going to show you. If I substitute 6 in for x and I do 6 plus 4, does that leave me with 10? And hopefully you're like, yeah, 10 equals 10. So we solved correctly. So there's always a way for you to check your work, which is really, really awesome. So you just have to take your time. You would apply your order of operations, which is from our first topic. Okay, our second problem, we're going to draw our line down the equal sign. We see our variable x. We're going to get it by itself, okay? And we're going to say, okay, that says x minus 5. I need to get x all by itself. I want to have x equals, right? So how am I going to undo that subtraction of 5? What is the inverse or the opposite operation of minus 5? And hopefully you're saying add 5, right? We told you they're opposites and inverses of one another. So we can add 5. We can apply that addition property of equality. Now, remember, if I add a 5-pound plate on one side, I need to keep it balanced and add a 5-pound plate on the other side. So I try to tell myself where I see that line, if I'm trying to move the minus 5 over to the right-hand side, I do the opposite of that minus 5, which is addition. So I think over the bridge, opposite operation, okay? So I'm going to bring that x down, draw my arrow. Minus 5 plus 5 goes to 0, so I don't need to write that. And 12 plus 5 gives us 17. So if you need to move this minus 5 over the bridge, you're going to perform the opposite operation. So remember O and O. over the bridge, opposite operation. That's going to come into play in some of our lessons moving forward. Okay. Our next example says 3 times x equals 15. Now I want to show you something here. I know that that 3 is being multiplied by that x, or they're being multiplied together because there's no plus or minus sign in between. The 3 is the coefficient for x, and whenever you have a coefficient, they're glued together through multiplication. So that says 3 times x, right? So we want to get that x by itself. So now we're talking, okay, what is the opposite of multiplication? How will we undo the multiplication property? And hopefully you're thinking division, right? So we're going to say, okay, the inverse of multiplication is division. So if I want to move over that 3 so I can get x by itself, the opposite operation is to divide. And if I do the opposite operation on one side, I need to keep it balanced and do the opposite operation on the other side. That's going to cross out those 3's because 3 divided by 3 will just leave us with 1. And 1x is the same thing as just writing x. And then 15 divided by 3 will give us 5. Now, once again, quickly show you, we can check our work. 3 times 5, we want to see, does that equal 15? We substituted 5 in for x. And yes, it does. Awesome. Okay. Our next example, we see x divided by 7 equals -3. So once again, I draw my line down the equal sign to kind of split up left-hand side, right-hand side. My goal is to get x by itself. And what's currently happening to that x is it's being divided by 7. So I want to do the opposite of division, which hopefully you're thinking to yourself, ooh, the opposite of division is multiplication. So to undo that division of 7 on that left-hand side, I'm going to multiply that left-hand side by 7. And if I do the opposite operation on the left, I have to keep it balanced and do the opposite operation on the right. Move it over. I want to move the division of 7 over. So the opposite of dividing is to multiply. And so remember, when we move over our bridge, we do the opposite. Okay, that's going to leave us with just a little x on the left. Now we're doing -3 times a positive 7. A negative times a positive will give us a negative. So we're going to have -21. And you can go ahead and check your work if you wish. Okay, our last problem looks a little bit different. We're going to draw our line here, and I'm going to write something off to the side for you. We'll do a color that we haven't used yet. We're going to talk about a reciprocal. So as you see here, we have 3/5 times x. So there's a couple ways you can go about doing this, but I'm going to show you the way that I think will be most effective for your math journey as you move along. So 3/5 times our variable x. So hopefully, or maybe you're thinking, okay, it's just 3/5 times x. The opposite of multiplying by 3/5 is to divide by 3/5. And that's not wrong, right? But what I want to tell you is, going back to something, maybe you talked about it in pre-algebra, that when you're dividing fractions, because you would be left with a fraction divided by a fraction, remember, when we do division of fractions, we multiply by the reciprocal. And what a reciprocal is if you have a fraction, say you have a fraction, I'm going to make up a random number here. We'll do 2/3, right? Whoops, I'm going to write it up here. The reciprocal is when you flip the numerator and the denominator. So it's saying, here's your fraction. If I give you a generic example, here's our fraction, a over b. The reciprocal would be b over a. You take the numerator and denominator and they switch spots. That's what a reciprocal is, okay? So when I see a fraction times a variable, and that fraction is like the coefficient. It's not like the prior example where it's just a denominator of 7. I can say rather than divide fractions and then have to multiply by the reciprocal, I'm just going to jump to multiplying by the reciprocal. So what happens here is if I multiply, so that's kind of the opposite operation, the reciprocal, multiplying by the reciprocal there. Okay? Because what you're going to be left with on that left-hand side is you're going to have 15 over 15, which is just 1. Because, whoopsie, these 5s are going to cross out, and these 3s will cross out. So you'll just be left with x. And then you can just go ahead and multiply 6 times 5/3, which will give you 30 over 3, which will simplify to 10. Okay, so it would not have been wrong if you did 6 divided by 3/5, but then you would have said, ooh, how am I supposed to simplify that on my own? Now, maybe you have a handy dandy calculator that will do all that for you, and that's okay, but maybe you don't, and so you'd have to remember, oh, when you divide fractions, we multiply by the reciprocal. So I would flip the numerator and denominator of that bottom fraction, and you'd see that we would get the same answer. Okay, so that is a very special case that when you have a fraction times a variable, we don't think of it as dividing the fraction. We say the opposite operation is the reciprocal, multiply by the reciprocal. So those are some of our examples. Let's slide down and just kind of wrap up what we just did. So we were solving one-step equations, and we know that we want to get the variable by itself, and in order to do so, we must apply the inverse operation to get x, or whatever our variable is, isolated. The same thing for inverse is opposite operation, and what we're doing is if we perform the opposite operation on the one hand, or on one hand side, we have to perform it on the other. So we have to keep our equation balanced, okay? What we do to one, we must do to the other, okay? If you see a fraction as a coefficient being multiplied by a variable, we're gonna multiply by that reciprocal. So I left you with 6 problems to try on your own. If you go to the details in this video, remember, there will be a blank copy of these notes for you to fill in on your own. You can either print or mark them up on a tablet of some sort. There will be a key to the U-Try, a PDF that will lead you right to a U-Try answer key if you want to check your work, and then a link to a video of a U-Try, where if you're stuck on any of these problems, you can watch that video and hopefully it will answer any or all of your questions. So I can't wait to continue with equations. It's one of my favorite topics in algebra because I think it's super duper important, and I hope you had a great time today. So please continue to watch our videos, and I can't wait to see you grow on your math journey.